started. I think everything's sounding good and working right. I need to make sure that I mute myself though, so you don't hear me twice. There we go. And we got quite a few questions, so I don't want to take too long and just dive into them and see if I can answer them all in a relatively quick amount of time. And I'll just say, hey, hello from the Arctic. Interesting. It's gotta be cold up there. I'm freezing over here in California, so I can only imagine. All right, let's get going. Jump over to our Sheets view. Make sure that that's showing up right. Looks good over here. Okay, and we'll start with controller questions. The first couple questions actually were about controllers. And the first one was, prior to lesson 10, should we be able to plug in a controller and move left and right? The answer to that is yes. Generally, if your controller is being detected and working in Unity, you should be able to plug in just about any controller and move left to right. I'm using a PlayStation controller right now, but I also used an arcade controller over there that I'll show you guys later. And I've used Xbox controllers, cheap little $5 game pads, Bluetooth game pads, and they all pretty much worked the same, where they just, as long as they show up in Windows, they work completely fine in Unity to move left and right. They read the horizontal and vertical axes, and then one of the buttons will be fire one on there. So we'll talk a little bit more about that. I want to hit the other two questions here, though. It says, I see that my computer is recognizing my controller, but I don't know if Unity is. I connected it prior to loading my Unity project. Is there a way to determine if the controller is connected? Also, if having problems, any troubleshooting suggestions? So there actually, there is a way to determine when a controller is connected if you connect it while Unity is already running. You'll actually see a log message appear saying that a controller was added. Now, for anybody who's having a problem getting their controller to even show up or just isn't seeing a controller, if you're in Windows at least, it should look something like this. I'm going to switch over to desktop mode. Once you turn on the controller, before I turn this on, it was just an empty list there. As soon as I turn the controller on, it shows up as an option here in my game controllers. And you just hit start and then search for controllers, and you'll find setup controllers, or where did I find? CONTROLLERS. Yeah, set up USB game controllers. That was it. It's not USB, but it's Bluetooth, but it still shows up under USB game controllers there. So once you have that there, you can just double click on it and open it, and you'll get this little properties dialog where you can move your controller around and see that it maps up and moves along the horizontal X and Y axis. And then you can see where the buttons are mapped up to as well, like which button number they are in here. And then you'll see that these are axes as well that are marked as, I don't know what they are, rotation ones. So anyway, that's a good place to go just look and see if your controller is actually working before you try to get it into Unity. If it's not working in here, then there's something else that you'll need to do, probably a driver setup. But most controllers don't need anything. They just plug in and get going. And like I said, this one's a Bluetooth. There was Bluetooth built onto the motherboard. I just added a Bluetooth device and synced it right up, and it works. Okay, and then again, for seeing it in Unity, if you do it or you set up the device or add the device, really just turn the controller on or plug it in while Unity is running, you'll see a little log message in there that says a new controller was detected. I forget the exact text of the message, but it'll show up right down there that there was a controller added in. All right, in multiplayer, let's switch back over to Sheets view. In multiplayer, we currently have it working with one controller or a controller and keyboard to control player 1 and player 2. How can we set it up to have two controllers connected and one control each different player? We're actually going to talk about that in a lesson a little bit further on, but there's not too much to it. Essentially, what we have to do is limit the axis movement ones to a specific controller number. So where we chose any joystick, we'll choose joystick 1 and joystick 2. And then for the buttons, it's a little bit different because we use the key or mouse button one still. So the way that it goes at, or the way that it gets typed out is instead of being like button 0 or joystick button 0, it'll be joystick 0 or joystick 1 button 1, joystick 2 button 1, or so on like that. So we'll index them and say which number they are. It'll be 1 and 2 essentially, joystick 1 and joystick 2. And then the button number off of that. So it'll just be like this long, kind of weird and ugly name, but it's not very complicated. Just see how we do it when we put it in there. It's just the more confusing part is that the axes part depends on what controller is selected, because we read an axis and we have to actually match that up to the buttons that use the text thing. So a little bit confusing there, but it's not too complicated once you get it down. All right, controller dead zone depends on the actual controller, so it may be a good idea to let the player change it. Since we assign dead zone values in project settings, it looks like it's non-controllable from code. Do we need to filter raw input numbers to do that? I do think that we would have to filter it ourselves. I don't think that there's a way to go in and modify that stuff from code. I also don't know of games that really allow you to do it. We usually just have some sort of a dead zone area so that a controller that's a little bit beat up isn't going to have an issue. But if the controller is just really bad and it's going beyond what our default dead zone values are, we don't necessarily need to address it. People just know that they have a bad controller and they're having the same problems in every game that they play, I think. So it gives us a little bit of control there, and we probably don't need to modify it too much, really. In most games, we'll just leave it around with the default values. But sometimes we want to have a little bit more control for our specific game. Like, we don't want our character to start moving at all until they've pressed like halfway on the controller or something. That's another way we could do it. But it's really just there for a little bit of fine tuning and adjustment. It's not something that I think I've seen players have control over in very many games. I think I can think of one or two in the past where there was some control over dead zones, but in general, it's not something that we give them access to. All right, coroutines. Let's scroll this way because I don't want to spoil the next one. In video 9, we use the code this.enabled equals false to turn off the script. But then how does Unity know to finish reading the rest of the code below, the fading stuff? Will Unity can read anything in this script again? So when we disable the script, it won't actually stop the execution of the code that we're running. So the code that we're running will keep going after that. What's going to happen is it'll stop running any update loops on it, and it'll stop responding to collision events. So it'll stop responding to things like a non-collision enter. Essentially, the script will stop doing that. We're turning off the script's interaction with the system, but we're not ever stopping the execution of the code by disabling that component. We do stop it when we do something like a destroy of that component. So if we just destroy the game object that we're on, we're going to stop our code right there. And that's what happens when we do that load scene async. So we don't want to do sorry, getting myself a little bit mixed up here. But yeah, essentially the code's going to keep running through the end of that method there. It's just not going to keep doing updates, and it's not going to get further collision calls or anything else like that. Okay, wouldn't the die coroutine execute all of our component disable statements on each frame until our slime fades away? How do coroutine loops work? On top of that, should we care if our alpha may not be 0 or even below 0 since we use delta time? So I wanted to bring up the code here and just share it because without it, I think that the context might be a little bit hard to understand. What's actually going on here, or the question is about whether or not these enabled calls are going to get called every single frame. They're actually not, just because they're not inside of the loop. What's actually going to happen is this IEnumerator, or this method, this die method that returns an IEnumerator, it's a coroutine, is going to run, and not the frame that we call start coroutine, but essentially the next frame, we're going to start running through this code. And we're going to run all the way through the code in this one frame and do all of these things. We'll get the sprite renderer, swap the sprite, disable all of these things, and keep going. We'll get into this while loop, and alpha will be 1, so we'll go into it. And right up until we hit this yield return null, all of that code will run in the first frame after we start our coroutine. Next, we'll wait a frame, and then we'll decrement our alpha, change the alpha here on our sprite renderer, and then we'll come back to the top of this while loop. So it gets to the end of this one, goes right up here to 87, and starts again, where it'll stop and wait for another frame. This yield return null is just going to wait until the next frame. Then it'll repeat the process. So it's going to repeat this code over and over every frame, but it's only going to run the stuff before the while loop once, just the one time, and then it'll keep going on until the alpha gets down to essentially a number that's going to be less than 0, or it's going to be 0. So, well, the alpha value will get less than 0, but our sprite renderer's color will not actually go to a value less than 0. And that was kind of part of the next question. So on top of that, should we care if our alpha may not be 0 or even below 0 since we use delta time? So what they're saying here is essentially like, imagine alpha is at 0.01, and we subtracted, I'm going to use big numbers here, bigger than we really would, So it's at 0.01 and we subtracted 0.02 because we have really slow frame rate. And then it's going to get at negative 0.01. Is that a problem? The answer to that is just no, because it doesn't matter for our while statement. It's going to be less than 0. We'll bail out. And when we set our colors alpha here, if we put a number less than 0, it's just going to make a 0 for the alpha color. So it doesn't matter. It's not going to be an issue either way. So there's no problem with subtracting it. We don't need to add in the extra code to do the check to see if it's less than 0. So good questions, though. All right, let's go on to camera-related questions. Is there a way to have the camera work better? Right now, when player 1 jumps, you lose vision on the bottom of the ground and player 2 disappears. Do they need to be added to the camera? Yeah, so we're going to be working quite a bit more on cameras. We just need to have more things that we want to track and being able to keep track of what things we want to have on the screen at a time. Then we can set up a little bit of control with that with the target groups, and then we can use confiners to lock that down even more. We're going to get into that a little bit more as we go along. We started adding in some more advanced camera stuff very recently, and we'll be, I guess, continuing on with that. Let's see. Are we going to be making the camera split screen for multiplayer? That was not something I was planning on doing. We're going to expand it out and then shrink it back down, but I was not planning on doing a complete split screen. I don't know that it makes a lot of sense for this type of game. It's not hard to do, though. If you want to make a split screen camera, it's actually a relatively simple process. Getting it, if you want to do the kind where it splits apart and comes back together, that's quite a bit harder. But if you want to just do like an actual split screen where you have like a top and bottom or something, or like a 4-way split, it's pretty simple. You really just set up 4 cameras, and then you can choose where those cameras render on the screen. You can set it up so that one camera renders on the top part, one camera renders on the bottom part, and you're pretty much done. I mean, I'm kind of simplifying it, but it wouldn't take you more than maybe a couple hours at most to get it figured out and get it running as a separate split out screen with a tutorial or two. And maybe it's something, if there are a lot of people that are interested in it, maybe it's something we can dive into later or in one of the upcoming courses. It's an interesting thing. It's just not something that I was planning. There's a lot of other code related things that I wanted to cover. All right, physics. Will the physics or the raycast method normalize our supplied direction or just multiply a vector by distance? It'll normalize it. So if you're saying if you give it a direction and you pass that into a raycast, you're also passing in a distance. It's going to normalize that vector. So yeah, it's a good question though. Let's say you have a game object with a rigid body component on it. We set our velocity to be equal to vector2.left in our update. How come the object is still pulled down by gravity? Shouldn't our vertical velocity always be 0 in that case? If we're setting it to vector2.left every frame in our update, then yes, it would be 0 always. If we don't set it to vector2.left every frame, then no, it would start to fall almost instantly. If you're not seeing that, I'm trying to think of why. I can't think of any reason that would not happen. I'm curious to see where you're seeing that though. Unless I'm thinking, I may be misthinking this. Let me get back to you on this one too, and let me just look at the code and the thing I'm thinking of. I could be mixing myself up. Okay. For player ground detection, we use the overlap circle method. Raycast method from Slime looks like a more elegant solution. Could you compare the two as an experienced game developer? Maybe share some examples from real projects. The answer here is really that the Raycast generally probably is a more elegant solution. The overlap circle is another way to do somewhat similar collision detection or area detection. And I honestly wanted to be able to show both. I wanted to show that we can do these overlaps. We can also do a raycast and make sure that you know that there's more than one way to do it. One of the benefits that we're going to get from the overlap circle though is going to come when we do wall jumps. So we can kind of put just move the circle area over and not have to worry so much about the raycasting direction or setting up multiple rays or anything. We'll just set up a single circle there and it'll work. For performance, it's not going to make a difference either way. It's going to be exactly the same. I mean, not exactly the same. The raycast is going to be a little bit more performant, but it's not going to be noticeably different in our game or in most games, right? We're not going to run into a case where switching from overlap circle to raycast or something was a big performance benefit. It just does give us tighter control over exactly where we want to detect those collisions. But usually we end up doing more than one of them if we set up raycasts. We have to set up a couple of them to figure out our exact area that we want to check. But yeah, there's not a huge difference. Really, it's just that I wanted to make sure that I cover a lot of these things because there are many different ways to do this stuff. And if you only know about one or you get stuck with one, sometimes it can be hard to understand that there's like a much easier solution. Sometimes we just want to see if there's anything that overlaps in a sphere area. And if you don't know about overlap circle, then you may end up doing raycasts all around or adding a trigger or something else and not know that it's there. So it's, again, just another way to perform somewhat similar code, and it'll actually be a little bit more beneficial than a raycast when we jump into wall jumping stuff. All right, should we care about positioning our sensors precisely? What if we didn't have a little gap between a down-facing ray and the ground, or a forward ray was a little longer, the colliders wouldn't have collided? Is this a reliable approach to just fine-tune the position? Yeah, you're going to want to fine tune these types of things. When you set up a sensor like this or some sort of a array area, you're going to want to fine tune it pretty tightly. A lot of the time what will happen is the game designers and the testing department or the QA guys who are very into it will really want to sit there and help tune those things down, or they'll tune it themselves and get it so that it feels perfect. Because they're not just looking at the code and trying to figure it out. They're moving the object there and jumping constantly, or moving the object and seeing exactly how it responds and just making the little tweaks there to get it perfect. It's the kind of thing that yeah, you do somewhat near the end, or in the tuning and adjustment process where you'll go through and start moving those things around, or yeah, you can do it along the way as well. But a lot of the time I let the game designers do that. They'll jump in and start tweaking things and make it feel perfect. All right. We have our own Mr. Slime who knows how to not fall from cliffs. Imagine we have a pretty long level with a lot of slimes. What happens if you just jump over them and they go off the screen? Should we destroy them to save computing resources? Another case would be if those slimes are far ahead. Would they still be calculating hits with raycasts, even being off screen? Should we enable our slime script when we see them? How do you deal with such cases when working on a big game? So it depends. There are scenarios where you would want to do this, where you would want to disable them and do it primarily for performance, right? You got a really, really long level that's going to go on for quite a while, and it's a performance problem on the devices that you're deploying to, especially if you're going out to a mobile device or something, or even a web player, I guess could be an issue as well. So if you're in that case, there are a couple of different options. The easiest one is to just enable or disable things based on their distance from the player. So you could add a single script to all of the objects that just enables them if they're certain distance away from the player, and disables them if they're too far away. But a better way to do it, or a slightly cleaner way, is to just set up chunks of areas. So we can set up like a region of our level and then just turn that region on when we're in the region before it. So imagine we've got like this chunk that's maybe 3 or 4 puzzles wide of stuff on our level, where you might see like 10 or 20 slimes at most. Maybe there's probably like 5 or 10, right? And then you've got another chunk after that that's got the same, like another 5 or 10, another chunk after that. The way that it would work is you would have the chunk that you're in enabled. So imagine this is just a parent game object like section 1, and it just turns on. It's on when your player enters a big collider for it. We put up a big 2D box collider. When our player enters it, we turn that object on, and all of the children turn on. And we turn on the one right next to us, the one just past us. And then when we get to that one past us, or maybe we'll turn on the two, the one right behind us and the one right after us. And then we can just start turning the ones that are not one behind us and one after us off. That's one of the easier ways and more common ways to do it. Another way that you can do it that's even more complicated if you get to much bigger ones is to start managing the level in either multiple scenes, where you're loading the scenes in additively and asynchronously. So we get into an area and I start loading in the other one asynchronously, and then get it ready so that when my player finally gets to that area, it's already loaded and ready to go and initialized. That's more for games where you're going to be going on a really long time and you're not going to be able to keep all of that stuff in memory. It takes a lot more work and it's a lot more complicated, but there are some games and some scenarios where you need to go that way. A lot of the time, though, you don't need to do any of that, and you can just do something simple like disabling their logic when the player is more than 300 meters away or 200 meters away, or just turning off the entire areas and then turning them back on. It just depends on what your game is and what the actual performance problems are that you need to solve there. The biggest thing I would do, though, is make sure that you profile first and make sure that you're solving the right problems and you don't spend a lot of time solving non-issues. A lot of the time we can do that where we kind of pre-plan what we think we need to optimize, and it ends up that the thing that we actually need to optimize is something completely different that we weren't prepared for at all, and we're optimizing a thing that's like the minor part instead of the big thing. So that's all. Just profile, and yeah, you can do a lot of stuff to improve performance there with these kinds of guys and just disabling stuff. All right, because of a capsule collider on our player, he may end up sliding off the edge of a platform or running over small obstacles. This behavior is controlled by physics. Yep, without knowing how the physics engine will influence our movement in all possible scenarios, we may have a buggy game in the end. Well, yeah, I mean, we'd have a game where we wouldn't know the exact behavior, right? How do I make sure that everything is going as expected? Examine the maximum height of an object, which a player won't be able to slide over. What about other cases, which I may just miss? How do experienced developers deal with this stuff, and do they rely on physics and test each game as hard as they can? Yeah, it comes down to deciding how you want those things to work and then making the adjustments for it. So if you don't want them to be able to slide down off of there, I'd switch away from a capsule collider, at least for the bottom part. You may want them to do that little bit of a slide when they hit on their head, or like kind of bump and slide off and leave it rounded there, and then maybe add a box collider for the bottom part to prevent that from slipping or sliding down. If you want to have them slide more, you can obviously adjust that collider more. You can have multiple colliders for your character, though, so you can kind of mix and match them, or you can build up your own composite colliders or custom polygon colliders too. So for that exact scenario, it'd really come down to just adjusting the collider the way that you want. You can, however, also alternatively just completely take over control of the character and not use the physics system at all. I wouldn't generally recommend it, though, just because unless you have a very specific plan of exactly how you want your character to control and you know exactly how you're going to do it, you're probably not going to get a lot of benefit out of it. You will get the benefit that you know exactly what's happening with it, exactly why it's moving and where it's moving, but you lose all of the built-in benefits of the physics system, or a lot of the built-in benefits of it, and kind of recreating a lot of that from scratch. So I would say you got to figure out exactly how you want the character to feel, and then before you build out too much of the levels and too much of the game, you want to get that part kind of tuned down. You want to get them feeling exactly how you want them feeling, right, and then start building out your actual game. Now, that doesn't mean don't build out like a prototype of your game and wait to get your character feeling perfect before you do that. I would say build out the prototype, get like a little level or two, get it going, and get it feeling, maybe it doesn't feel perfect, but get it so that you have a couple different things to test against, so that when you're working on making it feel exactly how you want it to feel, you have actual things to test on, not just like a tiny little mini level. You want to be able to play through, like, what does it feel like in these different scenarios? Am I missing anything in my code or in my thoughts about how I'm planning this out? And does it feel exactly how I wanted in these different areas? Like when we get into adding buoyancy and water and stuff, or even when you're talking about going through one-way platforms, things like that. You're going to be able to make sure that you have all these things ready to just kind of test and figure out the feeling. Also, it's worth noting that there are some cool 2D platformer assets on the asset store that give you different types of control, and they have pre-built character controllers. I wouldn't dive into using them right now just because you're not going to learn the coding side. It's much more about just building out a 2D game and making it so that you can build a game without having to write a lot of code. But yeah, they're cool and interesting ways to build different character controllers in 2D too. And you can find them all online and go through all their code too. And they're not very expensive. I think they're like 30 or 40 bucks for the more high-end ones of the 2D packs. All right, I'm going to jump to the next question, which is, since we use the slippery tag on our icy ground and do the check in our player script, our slime won't be slowed down by the surface. We could write a script for our icy surface instead to slow down colliding objects. Is this approach viable in a real game? That is something we could do. We would just want to make sure that it was something that we wanted to happen for all of the objects. Another way that we could do this, though, is make it so that our slimes or any of our enemies that walk on the ground can be modified or have their speed modified by the surface that they're walking on. So what we could do is have just a speed modifier that's a variable, or it essentially be a component that we'd attach to a surface. You could attach a speed modifier to the slippery surface, or we could even use the slippery tag. Two different ways we could do it. And then the slime could have another component or part of the slime that modifies its speed based on what it's walking on. So if it's walking on slippery things, maybe the slime speeds up instead of slows down, but other things slow down instead of speeding up. Or we could really vary it that way. So then we wouldn't just have the one surface controlling it, but we could have the enemies or the entities that are walking on it control how they respond to that different type of surface. That way our players and our slimes don't have to respond exactly the same. And even player 1 and player 2 don't have to respond exactly the same. We could have one character that works really great on ice and is able to control themselves good on ice, and another that does terrible on ice and just kind of slips around and, you know, even does other weird things like falls over or something. So yeah, these are all definitely approaches that we could use. The having it modify the speed when we directly walk on it is probably the scariest, only because if it's actually directly affecting the speed variable or a speed variable on the actual character or the player, then we end up with weird scenarios where different things could be modifying that speed variable. So I wouldn't necessarily have the object do the surface do the change, but have the character or some component on the character do the change. Or not really do the change, but note the multiplier and adjust its speed based on that multiplier. I wouldn't actually change the speed value. Okay, how can we make our slime pass through everything except walls? Just use tags or layers on every game object, or is there a more reliable solution? Tags and layers are relatively good options. We'll want to use layers to prevent them from colliding, because otherwise they're just gonna collide with the wall. So we'd have to make a wall layer that just isn't collidable by snails, or a wall that they can walk through. Or maybe we'll just make a like a wall and an impenetrable wall or something, or a special wall that they pass through. I'm not sure what kind of a wall the slime would pass through. I'm having a hard time picturing it, but I would think that would probably just be a special wall instead. Okay, what if I want my players to be able to walk through each other? How can we make those rigid bodies stop interacting? Oh, sorry, I lost my train of thought for a second there. That one's actually really easy. So if we go into the physics 2D settings of our project settings and look at the 2D collision matrix, if we just uncheck player and player, they'll stop colliding with each other. Right now I'm leaving them colliding because I want to do some fun little stuff where we can jump off of each other and mix the two players and give the advantage of like jumping off one player and then bouncing even higher to get further. But it's a very easy thing to make a change for. You just toggle that little setting right there, and then they won't collide with each other. And then if we want to make it so that they can alternatively collide with each other, we can just change their layers at runtime. And then we can make it so that they collide with each other and then don't collide with each other. So yeah, we could put them on separate layers, so that they, and then change that. But really, I think what I would do is just swap which layer the player is on at runtime, whether they're on the colliding players later or non-colliding. If we really wanted to change them, I think I'd probably pick one mode or the other though, unless we did some kind of special power up or something. All right. Should we make a prefab from any object we add to a scene? Is there a performance hit? So we shouldn't make it for any object, only any object that we want to reuse. A lot of the time that's most of our objects in a scene, but sometimes with our level building and environment stuff, it's not necessarily everything. So you'll find that as projects get bigger, more and more things are prefabs, and almost everything becomes a prefab as a project becomes really, really huge. But that's really not around, it's really around management of the project. So that if we make a change to whatever, this tree or these colliders or this whatever vehicle or piece of, I can't even, there's a million different things that it could be. A lot of time it's just like a character, but if we make a change to it, we want it to update everywhere in our game, not just in a specific one level or one spot. So it's usually just environment type stuff that ends up not being a prefab. And you'll see that we'll start turning more and more things into prefabs as we go along and start setting up more levels. Okay, when you started disable, oh, and is there a performance hit? I missed that part almost. So there is, it actually shrinks down the file and the loading. I think that it does take maybe a tiny bit longer to load a prefab, but it's not a noticeable, there's no downside or performance reason that you would not want to use prefabs. You shouldn't avoid prefabs for performance at all. That's definitely not a thing. When you started disabling components on Dead Slime with the enabled field, I thought that this field was inherited from a very base class each component derives from. Yep. So in my head, enabled should have existed on every component. You would think, right? And then comes the rigid body with no such field. Now it seems my initial assumption was not right. Is there any other Unity components which differ? So I think your initial assumption actually is right, that it is a field that's on the mono behavior. And I'm not sure exactly what they've done there, but I think that they've just sealed it so that it can't be accessed. And they've made it private inside the rigid body so that you can't get at the enabled field anymore. And in the transform. So there are the two spots where you can't change it. It's not something that I've thought about enough because I guess I vaguely remember seeing that and seeing that there was no checkbox there when I first started with it, and then not thinking about it again. But it's a really good observation. It is essentially, though, a mono behavior property, and every one of our components that we create is going to have it, and almost every one of the components that you see and use will have that available. Some of them might not show it in the inspector, but a lot of the time that's because there's a custom inspector that's causing it to not be enableable, or not be toggleable. Sorry, not enableable. But in general, yeah, most time you can just toggle on the enable, disable rigid body and transform, the only two that come to mind. There are probably some others where it's not accessible though, but I just can't think of them offhand. Okay, performance. At some point in lesson 9, you were calling get components within the die functionality. You said it didn't matter as you only call it once anyway. I'm used to always caching these and wonder whether it makes a difference in performance if you load it when you create the game object and then cache it in awake and start, or just use it whenever you need it only once, and it's only used once. So it would depend, right? If you really want to minimize the calls to get component and really optimize it, then doing it in the loading part might be better, right? So that you're caching them all in the load. It's still a very, 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 very tiny call. And the performance call of making a call to get component when the one guy dies, just when they're literally just dying, it's such a rare event. It's not going to make a difference if we cache it. And caching it, in that case, is really just going to add a bunch of extra code that we don't really need. The call speed is that when we cache get component, the reason that we want to cache it is because we're doing something that we're going to do over and over and over. I mean, that's the reason that we cache anything. It's so that we don't constantly get something or access something that we're going to use over and over and over, because it's faster to save it off and just get it the one time. Here, again, since we're only getting it once, it's really just about the time that we get it. We could get it before, right at the beginning of the level. It's not, I can't imagine a scenario where it's going to make a difference unless suddenly we're killing 1,000 of these things all at once, and then we're going to call the die on all of them and make 3,000 get component calls. Maybe then we get a little bit of a noticeable thing, but that's definitely not the case for this game or this usage for it. And just something to note, like get component calls, just they're not that terrible. You just don't want to do them every frame, especially not for a bunch of objects. Okay, let's go on. Regarding day 9, there are a couple of things I've done differently, and I was wondering why they weren't used. Why use 2 sensors and the flip X property when you can just use one and the scale X property to flip this slim? I'm not sure what that meant. To flip him, I think that's a typo. Why use a sprite renderer to the sensor when you can assign why add a sprite renderer or use a sprite renderer to create the sensor when you can add an icon to it, and that way don't have to hide it afterwards? 2 good questions. So the first part is about why we don't just use scale X. If we set it to -1 it's essentially going to flip the entire character over. It's kind of the same as rotating it. The problem that I've had with that is that when I set it to scale X, I start to get weird collision problems. Or sorry, when I set the scale to negative values, start to get weird collision problems. In the past, I've also run into a problem with deployment to one specific platform. I can't remember which one it was, if it was iOS or one of the console ones, but one of them just bugged out instantly when I tried flipping the X. And this was quite a while ago, so that may have changed. But in general, I found that just trying to set the scale to a negative value caused some unintended consequences and tends to break things, and things don't exactly or don't always work right when the scale is flipped over, especially custom code that we write to deal with colliders and stuff. So that's one of the reasons. And I also just felt like the scale X felt kind of hacky. It was, again, something that I did in the past multiple times, but it bit me too many times and it felt a little hacky. So I figured we'd just do it a little bit cleaner, add the extra code, and use the properties that are there for us already. Now, the other question, though, was why use a sprite renderer to create the sensors when you can assign an icon to it and don't have to hide it later? That was really just to show the process of it. And we will assign some icons to some of our sensors and other things later. The icon, by the way, for anybody who's not familiar with it, it's just a little dot kind of up in the top right corner in the inspector, or I guess top left of the inspector. We can assign to an object that doesn't have any visualization on it. We can assign to one that does have visuals, but one that doesn't have visuals on it, it'll show that icon in the scene view, and then we can kind of click on it and see where it is and stuff. Setting up a sprite renderer is just another way to show that we create the object. But we can do it either way. It doesn't make any difference at all. And in fact, like I said, we'll be doing icons later. So sharing. Would you like us to share our custom levels with you in the community? In that case, how do we do it? Exporting, sharing the whole project through Discord, email, or another website. Yes, I was actually going to start pushing for and requesting that at the end of this week. If you already are ready to share and you think you've built up some cool stuff that you want to share, building it out to itch.io or simmer.io is a great option. If you don't know how to do that, I'm going to cover it eventually. So we'll show you how to get your game out there and shared so that other people can try it out and play it and see what your levels look like. Another thing you can do, though, in the meantime, is just take some screenshots, post them onto the Facebook group of the stuff that you're experimenting with, the level designs that you're doing, and ideas or things that you want to try out. I've had quite a few really cool ones come in for just essentially level design ideas that also include a little bit of game mechanics, and I'm seeing which ones of those I can work into some of our upcoming lessons. I think that they're cool, and if it's stuff that everybody's interested in and wants to do, and it teaches us how to program, and we're learning some code there, and we're learning new techniques and new programming things, which is the most important part, then I'm all for it. So if you have some of those, please share them, drop them in the Facebook group. Also, feel free to email them to me directly. I like to go through them and look at them, just see what everybody's doing. All right, let's go down to miscellaneous questions, our last section. Are we going to learn how to create a simple online multiplayer game too? No, not in this one. And that's mostly because creating an online one is never simple. It's multiple weeks of getting it all working right, and there's a lot of debugging involved. It is something that I'd like to cover soon, and I want to talk about in the next parts. So it says, I got some questions about the full path, beginner to expert, and this was a very, very long question. I read the whole thing, but it essentially matched up with what the next question was, which is, will the other courses be updated? And if so, will we get those updates with no extra cost? The other part of the question before that, though, was like, are they going to be similar when we do these updates? Because the answer is yes. On the last one, we're going to be doing updates on both of the other courses, the intermediate and expert level stuff. And I do want them to be, I think, in a very similar format to this. I'm still working out the final details. I really want to focus on making sure that this course goes perfect as well first, so that it's really my main focus. So get that done, and then we're going to go on to, essentially, I think probably something very similar for intermediate and expert level is the plan. But again, I want to get through the end of this one, make sure that everything goes right, and see if there are any lessons from it, anything that goes really well, or anything that I think I can adjust and make better, and then work that into the next ones. So yeah, and I'm excited for those too. And again, that might be where we'll work in multiplayer, or maybe split out multiplayer into a separate, or didn't say multiplayer, online networked multiplayer using something like Mirror. I'm going to split that out into a separate little mini thing or something. I'm not sure exactly, but I'd like to do some online multiplayer stuff very soon too. Okay, I think that was all of the questions. Again, if you have more, just email them to me. There were a couple that I got that were about other things, and I sent out emails about those. I'm going to do some quick little mini recordings and just answer those and email them directly back. They were just not about the lessons in particular. And then, yeah, if anything else pops up, just shoot me an email. I'm going to go get a drink and then start recording those.